Hey, Brian here. Okay, so you did it. You joined the Cam Chain Tensioner Bolt Strip Club. Now, I've been to a few strip clubs in my day, so no judging here. But this is not one you want to go to. But you're here, so let's see what we can do to help you out of this mess.
Don't worry, I can fix it.
For those of you who don't want to watch the entire video, right after this introduction is an overview of the thread repair using a Time-Sert repair kit. Two options are shown. The first requires opening the top end, then moving the tensioner rod back out of the way. And the second, well, it doesn't. They both have advantages and disadvantages that are discussed in the overview. Following the overview is me doing the full repair. A big shout out to the guys on the CB900C forum, which covers early 80s Hondas like this one. Many there have done this repair, and I got a lot of good ideas from them. Now, here's my sexy Australian AI assistant with the overview.
Thank you, Brian. You're awesome. Now let's get into the repair details. The upper cam chain tensioner bolt design is a weak link to an otherwise bulletproof engine. The bolt installation is shown here in a simplified cross-section viewed from the front. Note the threadless relief for the locking bolt in the top half of the hole. This makes for limited thread length in the aluminum block. This relief is important to understand for the final repair adjustments, as will be discussed later. When the bolt is torqued down to hold the chain tensioner rod, it puts strain on the aluminum threads. Additionally, when the locking nut is tightened, this adds even more stress to the threads. This is why it is so easy to strip out. So, a thread insert repair will be needed. The following procedure uses the Time-Sert M8 by 1.25 thread repair kit, part number 1812. Option 1 for the Time-Sert repair is to push the tensioner rod back out of the way, allowing for better clearance during the drilling, tapping and insertion process. But this does require some disassembly of the engine top end, including lifting the intake cam to allow slack in the cam chain, which then allows the rod to be pushed back. Once the rod is pushed back, drill out the stripped hole. The Time-Sert tap drill is just slightly larger than the relief hole and stripped threads. Clear out the metal chips with an air gun or probing tool. Countersink the hole with the Time-Sert countersink tool. Thread the hole with the special Time-Sert tap. Clear out metal chips and clean threaded hole with solvent. Apply oil to the Time-Sert insertion tool. Apply thread lock to the insert. Drive the insert in until the insertion tool travels about 1/4 inch past the bottom of the insert, as required by the Time-Sert instructions. This causes full expansion of the insert into the block. Push the tensioner rod forward into its normal position, and test fit the tensioner bolt and lock nut. The new thread repair does not have the relief that the original hole did, so it will be necessary to make some adjustments. One option is to provide relief on the tensioner bolt by turning or filing a radius on the bolt. Do not make the relief less than the thread minor diameter, or create sharp edges, as this will weaken the bolt. Another option is to add a shim disc under the bolt to make contact with the rod. Repair option 2 is to make the repair with the tensioner rod in place. This has the benefit of not having to take the top end apart, but has other complications associated with it. The hole is drilled out, but there is a little bit of broken thread left at the bottom. Be careful to not damage the tensioner rod with the drill and to clean out the metal chips from the blind hole. Countersink as is typical. The hole is threaded with the tap, but the threads do not go all the way to the bottom due to the initial taper on the tap. Care must be taken to dig out all the metal chips from the blind hole. The threads could be advanced further by using a bottoming tap. But you would probably have to grind it yourself, and the Time-Sert tap is a special item, so you would have to buy 2 of their kits or find the tap alone. Insertion is complicated by the blind hole. The insertion tool needs to go 1/4 inch past the insert to properly expand it out. It is recommended that a 9mm insert be used instead of the 11.7mm insert that comes with the repair kit. Even with the shorter insert as shown here, there is not enough clearance to get a 1/4 inch past the insert. Though not optimal, this method of repair can work. The tensioner bolt will perform some of the final insert expansion. The same issue with lack of thread relief for the tensioner bolt applies, so adjustments are needed. And now, here is Brian to take you through the repair process.
This is my 1981 CB900 Custom that I've owned for about 25 years. And yes, I joined the strip club. This repair should apply to all late 70s to early 80s dual overhead cam engines, including the 750, 900, 1000, and 1100cc. Now let's get into the repair.
This is the Time-Sert repair kit we're going to use. It's part number 1812. Got it on Amazon for a little under $100. You have the drill, counterbore, threading tap, and the insert driving device, and the 11.7mm inserts. Now, because of the distance down to the repair area, you're going to need something to extend your reach, and they sell a extended tap handle that you can get. I didn't choose to go that route. I did something else. But if you do get a tap handle, be aware that the 3 of these are the same. They're 1/4 inch square on the top, but the tap is apparently metric and it's larger. It's about 0.279 inches. So whatever you get, make sure that tap handle will accept those 2 sizes. I bought a couple of coupling nuts, a 5/16 and 7/16 sizes. Make sure they're the coarse thread, and then punched them out with a drill of the same size that these are, the shanks, and then threaded and tapped a set screw in there. That way I can assemble that and then just drive it with a standard socket. You shouldn't need this tool. I created it because I removed the cam chain tensioner from the engine before thinking it all the way through. Even if you plan on replacing the tensioner assembly like I did, leave it in the engine and push the tensioner rod back out of the way for the drilling, tapping operation. Also use the tensioner rod to push the chips out the front. I showed this tool here for clarity because it will be seen later in this video. Remove the seat and gas tank. Mark the plug wires and remove the ignition coils. Remove the AC generator cover. Remove the fuel filter and tachometer cable. Remove the 8 valve cover bolts, the valve cover, and gasket. Clean the valve cover area of old gasket material and silicone. Remove the oil cooler line bracket on the front of the engine to gain better access to the plug seal.
Okay, to give us a little extra clearance in here, I removed the fender, and also I zip tied the oil line up out of the way. Normally gets in our way right there. We're going to drill and tap a 1032 hole in this. I created this puller with using these parts. Found a piece of tubing pretty close to what I needed in the shop. Some people say they just drill in there and use a drywall screw and pull that thing out of there. I'm going to put this back together, and I may not use this again, but I can put a short screw in there and a little compound on there and plug it up. Some people use a rubber grommet in there and throw a screw in there so they can get access to this regularly for adjustments. Using a socket and ratchet on the AC generator shaft, rotate engine clockwise until cylinder 1 camshaft lobes are facing each other and the cam marks are even with the top of the engine casting. Remove 2 cam cap bolts holding the oil line and upper cam chain guide. Then remove guide and the oil line. Remove 2 bolts and the cam chain A tensioner setting plate.
Remove the bolts and 2 inner cam caps on the intake cam. Loosen the bolts on the remaining 4 cam caps in a crisscross pattern, then back out the bolts and allow the intake cam to pop up evenly. If you are going to replace the cam chain B tensioner, move the intake cam forward, otherwise leave it in place loosely. If you are replacing the cam chain tensioner, you may want to leave it in place for now to block the hole during the thread repair. I pulled it out before thinking about using it in this way. Using a Phillips screwdriver, push the cam chain tensioner rod back until it is not blocking the stripped out hole. Remove the front engine mounting rod, then jack up the engine slightly to gain better access to the stripped out hole.
Now we're going to insert the chip plug to prevent chips from getting in there.
Okay, we're set up for step 1. I've gone ahead and wrapped tape around the socket to the drive nut there so we don't lose it on the way down there. And then we've marked the drill bit with tape 5/8 of an inch. Now you might be tempted, like I was, to drive this thing with a drill bit. Everything I read online was people felt it was a better idea to do it slowly with a ratchet or with the tap driver. And now that I've looked at exactly how this is going to work out, I can see why that's going to be a good idea to do it really slowly, because actually the top of the hole is the drill bit already fits into it. And if we started to try to use a drill driver to drive that in there, I can see this thing grabbing and yanking down there. Expose that really quick there. I C-clamped this actually a putty knife handle, but you can use a block of wood or whatever. Took a little messing around there, and you have to adjust it just right. But that's so I can rest that on there as we're going in, and it's lined up to be as straight as I can make it. Now remember, we did jack up the engine. Yeah, it's already starting to bind up on me, so it's dragging the drill bit in kind of like a thread because there's so little materials left there. So be real careful. Keep it sitting on your rest there. Back it off a couple times here every once in a while. Not typical for what you usually do with a drill bit, but there she goes. Now the drill bit's staying in one position rather than being drug in, and I'm at my piece of tape. So I think where we need to be there. All right, next up is the counter bore tool. It has a shoulder stop on it, so there's no concern about going too deep. Gonna give a little bit of lube on this one. Looks like it's got a ways to go yet. My bracket fell down there, but I think now that I got the hole piloted in there, we'll be all right. A little bit difficult getting pressure on this with the ratchet system, but I can see chips coming out, so it's working. I think I will end up using the drill on this one. All right, brought in the big guns on this one. Get a little more action there. I think we're there.
kind of hard to tell. Just looking at the bit itself and look at what we got there, it might still be a little shallow. So the other thing, the chip's riding along there might keep it up in the air. So it's not gonna hurt it any to keep at it. So, all right, did not produce any more chips. So I'm gonna say we're as far as we need to be.
We're ready for the third phase, which is to thread the hole. I've gone ahead and marked the tap at about 3/4 of an inch, but we'll also monitor ourselves by looking through the inspection hole. This is a 4-bladed tap, so it requires that you go in a ways and then back up as you go to break the chips. I added a little bit of lube in there, and we'll keep adding more as we go along. So I'm pushing on the socket, top of the socket as I go in, to start with going a ways, and then start backing off about 1/4 or 1/2 turn and breaking the chips. Go slow. Keep your alignment up. Once you get going though, it's set. Its path is set. Now all these chips are going into the bottom of the hole down there. So if you're doing this blind, you're going to have to stop every once in a while, pick them out with some sort of a tool. You feel it starting to bind too hard, don't overdo it. Back up. And if it really loads up, especially if you're doing a blind hole, bring her all the way out and check it. I'm checking the lower hole down here and I see chips falling down there, so we should be okay for this operation. And if you do bring the tap out, be very careful when you reinsert it so you don't start a new set of threads. You do not want to do that. Check my depth. Yeah, about 1/8 of an inch to go. I see lots of chips down the bottom, but they're not getting packed in yet. So I think we're okay there. Okay, and the tap just hit flat bottom, so we're done. We met the bottom of the drilled hole, so we're done. Now bring it on out. So we developed some burrs in there that's not allowing me to push the shavings on out. So what I'm gonna do here is we'll put the old pin back in there. If you don't have one, get one that's similar in size. And work it back and forth in there a little bit. And mess around it until you can purge it out and get all your slag out of there. So taking care of the burrs. And I think we're ready for the next step. But before we do that, we're going to make sure we clean it really good. They don't have anything in the instructions about using thread lock, but everything I read online says to use some. So we're going to use some blue thread locker on it. All right, we cleaned it out really good with solvent. So we're ready for the insert installation. So we've set up our insert device here. Now they say to be sure to lubricate it with some oil. They actually make a specific oil for this of all things, but then they also say that 30 weight lube will work fine. And then as I mentioned, they didn't really say anything about thread locker, but oops, came up kind of fast there. that we're going to put some on there. Actually sell a Time-Sert thread locker as well. Get started in there. The insert tool binds at the bottom of the insert, so they're threaded in nicely right straight in. Looks like it pretty much got down to the recessed shoulder there. Then you drive it in and it expands it out. We'll also have to keep an eye on hitting the bottom of our hole there too as we do this. Well, the instructions say you'll feel it hit the bottom of the insert, which I can feel it now. And it's starting the expansion process. I'm over here bent over watching it come through the hole. Make sure we don't hit the back side. I say go until you feel it ease up. In our case, we go until it eases up and we get all the way to the other side. Okay, it did feel like it eased up, and plus I can see it coming out. So here we go. Then you pull out the insert tool. Okay, we've cleaned off all the excess thread lock and then made sure everything's still free moving there, which it is. And looks like that's complete. Now we'll test the thread insert. All right. Put on a new O-ring. Got the clamping nut backed all the way off. Yeah, see, that thing is acting like it's hit bottom and it coming up tight, and I'm not hitting anything. That's very strange. I think the bolt's not long enough. Maybe this new, I don't know why that new insert would make any difference, but I did see one guy say that he had to put some kind of shim at the bottom of this thing. So I'll have to do a little more experimentation here, try to figure out what's going on. The insert looks great, but this is not working. So the original design, the hole, the very top of the hole of the aluminum block, there were no threads in it, and that's part of the reason why this thing was so easy to strip out. But that also allowed for this portion of the shank to get down in the hole further without bottoming out. So what's happening right now is we're hitting this in the insert. Now the insert itself has a slight lip on it, so it looks like I did not get the countersink deep enough, even though it didn't seem to want to go any further. I know some people have said that they put a little piece of metal in here just so that it has something to bite against when it goes in there. So I can see that as an option. I can also see putting this on a lathe and maybe turning that down, but then that's going to weaken that, which I've heard of people breaking these off even like this, which I can't hardly understand how they do that, because in the aluminum is always going to go. The other thing I could try is pulling that insert out using an extractor. I'm a little nervous about doing that, and then trying to redo the counter bore and get it in deeper. So we'll see what we're going to do here. Okay, I decided, since this is a very low torque application, it should be able to handle it, to go ahead and put a little relief on there. I use my lathe and a radius bit to do that. You probably don't have a lathe available to you, so it's easy enough to put this in chuck this up in your drill or drill press and use a little round file. I didn't go super deep. I'm hoping that when I crank this in here, I can push it past the last threads there, and it'll form them. And I'm going to put some oil on there just to make sure everything works out okay. And if that doesn't work, then I'll take it back and I'll add a little more relief to it. Okay, that seemed to do the trick. So I took off the jam nut, and then I threaded the main bolt all the way in without the tensioner rod in there, so I could push it all the way down until it hit that area that I was relieving a little bit, and it had some resistance, but then it moved right through. So I think it did what I was expecting, and is that it formed the threads and finished down. Then backed it on out, and then put the lock nut back on, and back the lock nut all the way out. Run this in, push the tensioner in from the wrong end, obviously. Remember, that thing is a tapered device, so when it actually works, the taper goes the other way, and it will not slide out this way. So this should work fine. And anyway, now that that's in there, and I crank it down, and that thing's tight. It's definitely hitting the flat and working. And then I check my lock nut capacity there. So see how many turns we get there. Still not tightening up, so that's good. Probably getting to the O-ring now, yeah. So we got about a turn and a half to lock that thing in, and we're completely pinched down. So that's as good as it's gonna get. All right, the repair is complete.
Okay, so that wraps up the thread repair. I hope you enjoyed this video and found it useful. As noted earlier, I replaced the cam chain tensioner assembly as part of this project, and I decided to do a separate video on that, which includes the top end reassembly process. If you need help on replacing the tensioner on the reassembly process, check out the link below in the comment section. Now let's go ride. Hello, Brian. Fuck that. Hello, Brian here. Hey, Brian here. And this is my 1981 CB Honda 900. Fuck. A big shout out to the guys on the CB750.com forum, which covers early 80s Broncos. Unbelievable. Repair, and I got a lot out of that from the fuck. And this repair that we're going to do should, I need to start. Why is that one to remove? So if you want to see the disassembly process and the cam chain removal, I was doing good, pretty good, and then I failed. Now to get this job done, I had to develop a few custom tools. Now to get this job done.
Okay, this is one of the specialty tools I created. Okay, so we marked our depth at 5/8 of an inch.
Are you just going to leave them in the house by themselves?